So here we are converting from rectangular to polar coordinates. Okay, so let's talk about how we do that. This first one, it says find the rectangular coordinates, which means this is your polar form. So this is your radius and this is the angle. Okay, so let's plot this real quick just so we can get an idea. So we go to 2 pi over 3, which is over here, but then the radius says it's negative, which means our point is actually down here, 3 units away along this axis right there. Okay, so we're in the fourth quadrant, so we should expect to have a negative or positive x coordinate and a negative y coordinate. Okay, because we're in the fourth quadrant, that is what we're going to get. So the x coordinate is always the radius times the cosine of the angle, so negative 3 cosine at 2 pi over 3, and the y is the radius times the sine of that angle, 2 pi over 3. Okay, and this is all we need to do to convert from a polar to a rectangular. So if you've memorized your unit circle, we know that the cosine at 2 pi over 3 is negative 1/2. And if you've memorized your unit circle, we know that the sine at 2 pi over 3 is positive root 3 over 2. So when I do this final multiplication, 3 times negative 1/2 is 1.5, or 1 1/2. And if we do this one, let's see, negative 3 divided by 2, that's negative 1.5 roots of 3. So if we're going to write this as a coordinate point, that would be 1.5 comma negative 1.5 roots of 3. Okay, and if you want to put that into your calculator, that's fine, even though the directions say give exact values, whatever. But we have a positive x and a negative y, just like we suspected that we should. So the x is always the radius times the cosine of the angle, and y is always the radius times the sine of the angle. Now the next one says find some polar coordinates. So we need to change this x and y into a radius and a theta. Okay, so how far away is this from the origin? So here's negative 5, and here's 5 roots of 3. So here's the point, negative 5 comma 5 roots of 3. So we need to figure out what this radius is, and we need to find this angle right there. That's the angle that we're looking for from the positive x-axis. So to find the radius, we simply use our buddy Pythagoras. So we have a y value of 5 root 3, and we have an x value of 5. So r squared equals 5 squared plus 5 root 3 squared. 5 squared is 25, and then we have to square all of our terms. Okay, 5 squared is 25, root 3 squared is just 3, so 5 roots of 3 squared is 75. So r squared is 100, so the radius is going to be 10. So this point is 10 units away from the origin. Now we have to find the angle. Okay, now there's a formula using the tangent to give us this angle right here. Okay, that's the right triangle that we're going to use, and we can find that angle by taking the inverse tan of the y value over the x value. Okay, and just make them positive, and you can do the math because you're smart enough to do this later, but just make them all positive and your calculator won't ever mess you up. So if we take the inverse tangent of 5 roots of 3 over 5, hopefully we find that this is a 60 degree, 60 degree angle. So this angle right here is 60 degrees. Okay, but that's not the angle we want. We want the angle from the positive x-axis. So if we subtract this from 180, that gives us a 120 degree angle. So as a polar coordinate, the answer is 10, 120. Or 2 pi over 3 if you are so inclined to use radians. So doing the same thing with this angle over here, first we're going to sketch it. 2 roots of 3 and 2 makes our point right there. So we need to figure out what this radius is by using our buddy Pythagoras. So r squared equals 2 roots of 3 squared plus 2 squared. So 4 times 3 is 12. R squared is 16, which means we have a radius of 4. So now we just have to find this angle right here. And because it's a first quadrant angle, when we use the inverse tangent, that's going to be the angle that we are supposed to have anyway. So 2 over 2 roots of 3. When you put this into your calculator, we get a 30 degree angle. So 2 roots of 3 comma 2 in rectangular is the same as 4 comma 30 in polar. To convert from a rectangular to a polar, we use Pythagoras, and to convert from a polar to a rectangular, we use r sine and cosine of theta.